Hello, teachers. I'm today's second speaker. My name is Wei Bochen, and I will introduce about the PCR. The PCR is a polymerase chain reaction, and it was invented in 1983 by a biochemist named Carey Mullis. Uh, and he is a biochemist, and it's a method widely used to make millions to billions of a copy of specific DNA sample rapidly, allowing scientists to amplify a very small sample of DNA specific to enable detailed study. And here is the principle. The PCR technique is based on the enzymatic replication of DNA. In PCR, a short segment of DNA is amplified using primer-mediated enzyme. DNA polymerase synthesis the new strands of DNA complementary to the template DNA. The PCR processing consists of three main steps, including denaturation, annealing, and elongation. So here's the component of the PCR. First, we will need to prepare the DNA template. It is the DNA of interested sample. And in on the other hand, we will need the DNA polymerase, and it is a polymerase from a tag, and it is kind of stable. It does not denature at very high temperature, and we will need specific primer. It is based on the known sequence of target DNA sequence. A short sequence complementary to the template DNA. And then we will need deoxyribonucleotide. It is a single unit of base used for synthesis of DNA. And we will need buffer system. Its mechanism and potassium provide optimum condition for DNA denaturation and renaturation. And here's the PCR uh, protocol. So first is denaturation. Denaturation occurs when the mixture is heated to 94 to 96 degrees for about zero point 0.5 to 2 minutes. And this will break down the hydrogen bonds between the two strands of DNA and converts it into a single strand DNA. The second single string now acts as a template for the production of new strands of DNA. The temperature should be provided for a longer time to ensure the separation of the two strands. And then is annealing. And in this step, the reaction temperature is lowered to about 68 degrees for around 20 to 40 seconds. The primer should be used. The primer are single-strand sequence of DNA or RNA and around 20 to 30 base in length. And here the primer bind to layer complementary sequence on the template DNA. They serve as the starting point of synthesis of DNA. The two separate strands run in opposite direction, and consequently there are two primers, a forward primer and a reverse primer. And in the end is the elongation. At this step, the temperature is raised to 72 to 80 degrees. The bases are added to the 3' end of the primer by the tag polymerase enzyme. This elongates the DNA in the 5' to 3' direction. The DNA polymerase at about 1,000 base pair per minute under optimal condition. The Taq polymerase can maintain stable at very high temperature. It acts attached to the primer and add DNA base to the single strand. As the result, the double-strand DNA molecules is obtained. Totally, these three steps are repeat 20 to 40 times in order to obtain a number of sequence of DNA of interest interested in a very short time. And here is the PCR advantage and disadvantage. First, the advantage of PCR is it got high sensitivity compared to culture and staining, and ability to test for antimicrobial resistance, and it can quickly perform in 4 to 8 hours, shown to be more cost effective with selective use than culture and staining. Increased ability to detect less common organisms such as virus. And here's the disadvantage. Um, Potentially lower specific compared to culture and staining. Need more narrow list of conservative agents to use specific primer, otherwise will increase risks for false positive. Supply cost and training expensive. And in the last, the PCR cannot measure the initial amount of DNA accurately, unlike qPCR. So now we can compare the PCR and the qPCR. Here are the qPCR principles. Uh, qPCR, or a quantitative PCR, as known as real-time PCR, is a technique that enables the quantitative analysis of DNA or RNA. Unlike the conventional PCR, qPCR allows the amplification process to be monitored in real time, providing immediate data as the reaction progresses. This is adherent through fluorescent labeling achieved. Here is a compare of qPCR and PCR. So first, the purpose. Uh, the qPCR can be the PCR is can amplify DNA, and qPCR can amplify and quantify DNA. And PCR, the key component of PCR is primer, and the key component of qPCR is primer and fluorescent probe of dye. And detection method of PCR is gel electrophoresis, and for qPCR is fluorescence during amplification. And for the application, the PCR can detect DNA present mutation and sequencing template. And for qPCR, you can quantify DNA, analyze genes expression, detect facile gene. And for PCR, it will cost longer time, and qPCR is a faster technique.